Hello everyone, welcome to the differential equation series, and today I'm going to talk about classifying the differential equation. The order. The order of a differential equation is the order of the highest derivative present in the equation. So let's say we have a second order differential equation. So d squared y by dx squared plus dy by dx plus y is equals to 0. So to determine the order, we have to look at the highest derivative. So the order is 2. In this differential equation, the highest derivative is d squared y by dx squared, which is, the order is 2. And another example, we have like if we have y triple prime plus y is equal to 0, the highest uh, derivative is y triple prime, so the order is 3. Degree. The degree of a differential equation is the highest power exponent of the highest order derivative present in the equation. So after the equation has been made free or of radicals and fractions involving derivatives, it must be a positive integer. So let's say we have d squared y by dx squared plus y is equal to 0. In this case, the degree of the differential equation is 2. Why? Because we look at the order, the highest order. So the highest order is 2. That means the degree is the power of the highest order, which is 2 here. Another example, let's say we have y double prime squared plus y double prime plus y is equal to 0. In this case, the highest derivative is y double prime, so we have order 2. And what is the degree? So we have to look at the highest power if in case we have like the same order. So we have the degree is 2. Okay. When does the degree is not defined? The degree is not defined if the differential equation cannot be expressed as a polynomial in its derivatives. This occurs on the following situations: when a derivative is assigned a transcendental function. So a transcendental function is like sine of y prime e to the dy by dx ln of y ln of y prime. And this makes the differential equation degree not defined because these are transcendental functions. Next, derivatives are raised to a fraction or negative power. So let's say we have y to the negative a half, y prime to the negative a half, y double prime to the a half, y to the prime to the negative 2. This makes the differential equation not have a degree, so it's not defined. The degree is not defined. And the three dependent variable are in exponent order of derivative. And if we have like dy by dx to the y, okay, and we have y prime to the negative y, this makes it not defined. The degree is not defined. Linear. The differential equation is linear if it satisfies all the following conditions. If it's not, it's called nonlinear. So the dependent variable y and all its derivatives y prime, y double prime, and so on appear only to the first power. So let's say we have y double prime plus y prime plus y equals to 0. The power of the derivatives and the dependent variable y it's only 1, so it's linear. It's not linear when we have like y double prime squared, y cubed, so larger than 1 or negative 1, less than 1, or a fractional power. And 2, there are no products of dependent variable y and its derivatives, and no product of derivatives with each other. So if we have like y times y prime, then it's not linear. And also if we have like y double prime times y triple prime, yeah, that's not linear. There are no rational functions of the dependent variable y or its derivative. So if I have like sine y, sine of y prime, e to the y prime, ln of dy by dx, ln of y, then it's not linear. These are not linear. Not linear. So let's go on to the practice. And question 1. X times the second derivative plus 4 times x times y equals to 2. In this case, what is the order? So the order is just the highest order, which is just the squared y by the x squared. So the order is just 2. And the degree. So the degree is determined by the highest order. So the highest order is 2. That means the degree is this power, the power of the highest order, which is 1. And is it linear? Yes, because again, there's no transcendental functions, and there's no transcendental of function of the independent variable and the derivative, and also there's no power that is greater than 1 or less than 1, or it's a fraction, or it's a negative power, and also there's no uh, product of the dependent variable and its derivative, and also the derivative with another derivative. So it's linear. And 2, y double prime plus sine of y triple prime. What is the order? So the order is the highest term, which is just y triple prime. So it's 3. And what's the degree? Again, the degree is defined by if it's the question is a polynomial. So, and here we have a transcendental function. That means it's not a polynomial differential equation, so it's not defined. And is it linear? No. Why? Yeah, because there's a transcendental function of the derivative, and this is not linear. The third question: what's the order? In this case, the order is actually we can times by y double prime to simplify it. We can to remove the radical. So we have y triple prime times y triple prime squared plus 3 plus y triple double prime. This is y double prime, not triple prime, sorry. Y double prime times y double prime to the second power plus 3 plus y double prime times y is equal to 0. So we can combine the power here. So y double prime cubed plus 3 plus y double prime times y. So in this case, the order is what? The highest derivative, which is just 2. And the degree is the highest derivative, and the highest derivative, and the so that means the degree or the power must be on the highest derivative, so which is 3. And is it linear? No. Why? Because there's a product of the dependent variable y and its derivative, and also the power of the order, the highest order, is it's greater than 3. So linear? It's not linear. It's not linear. And let's move on to number 4. In this number 4, we can divide by the x, and we have 3x plus 2y minus 2x plus sine of x dy by dx. Well, as you can see, the order is just the highest derivative is just 1. It's just dy by dx, so order is 1. So the degree is 1 because the power of the highest order is just 1. And well, is it linear? Well, it is, because it satisfies all the conditions. And sine of x, you might question, like transcendental function. This is sine of x. So x here is actually the independent variable. So it still satisfies because it's the independent variable. It doesn't satisfy if it's sine of y, like sine of y. So this is y is the dependent variable. Okay? Y equals a function of x. And number 5. We can take the square root, the square of this, left hand side and right hand side. This becomes the fifth derivative cubed plus 2 is equal to 6th derivative squared. And as you can see here, what is the highest derivative? So the highest derivative is 6. Is this 6 by the 6th derivative. So order is 6. And what's the degree? So the degree is the power of the highest derivative. So it's 2. And is it linear? No, because the power is greater than 1. No. So it's non-linear. Number 6. The third derivative times the third derivative plus xy is equal to 3 times the second derivative. So we can actually write the second derivative with respect to y. Okay, we can write the a squared x by the y squared as derivative with respect to y of the x by dy. Okay, and we can actually write dy by dy as according to quotient rule. The chain rule actually. Dy by dx times derivative with respect to y. Okay, derivative with respect to x. Respect to x. And This is the same thing as 1 over y prime, okay, and times with respect to x. So we can substitute d by y as this. One, I mean, 1 1 over y prime d with respect to x of dx by dy. Well, we can write dx by dy as y prime to the negative 1. Well, if we differentiate this, we'll have 1 over y accent negative y accent y prime to the negative 2 with respect to x of y prime to the negative 1. I mean, this y prime. Sorry. Y prime. And here we have negative y primes negative 2 over y prime with respect to x of y prime. And we can simplify this more in 1 over y prime cubed with respect to x of y prime. Okay. Well, wait, this is, yep, this is correct. Okay. And so we can write this differential equation as y triple prime times y triple prime plus xy is equals to 3 times negative 1 over y prime cubed with respect to x of y prime. Well, if we distribute this, we have y triple prime squared plus y triple prime times xy is equals to negative 3 by y prime cubed with respect to x of y prime is just y double prime. So we can times y prime cubed left hand and right hand side, and we have y prime cubed y triple prime squared plus y prime cubed y triple prime xy is equal to negative 3 what's this, y double prime. Well, as you can see, what is the highest derivative? Well, which is just our y triple prime. So highest derivative order is 3, and the degree is the power of the highest derivative, which is 2 in this case. And is it linear? Well, it's not linear. Why? Because there's of course the power is greater than 1, and there's a multiple or the product of the derivative and the other derivative, so it's not linear. And look at number 7. So y triple prime plus 1 over y triple prime plus sine of x y triple prime. Well, as you can see directly, this is not linear because of transcendental function, and we cannot make it as a polynomial, so this is not, we cannot not define for the degree. But we have an order though. So the order is the highest root, which is y triple prime. So it's 3.